Doing vectors means working on vector physical quantities. Some of those vectors can describe the motion of an object. So when one wants to describe the position vector of an object, it is preferable to have a reference point or a reference coordinate system through which this position vector can be described. The coordinate system, which has the origin as a reference point and three perpendicular axes x, y, and z, which meet at this point, is called Cartesian coordinate system. In two dimensions, for example in the x, y plane, the location of a point represented by x equal 4 and y equal 3 meters, for instance, with respect to the origin, is represented in Cartesian coordinate. This point can be transformed to another coordinate system, which is called the polar coordinate system, with an r and theta, where r is the distance from the origin to the Cartesian point, and theta is the angle between r and the positive x-axis. Here it must be noted that the two coordinates x and y form the two sides of the right-angled triangle that has r as hypotenuse. To find the angle, we need to use the trigonometric relation tan theta, which is equal to opposite side y to the adjacent side x. Substituting the values of x and y and having the tan inverse, the angle theta can be obtained directly as 37 degrees. However, the magnitude r is obtained from the Pythagorean theorem, where r equals square root of the sum of the squares of x and y, which is equal here to 5 meters. In such case, we can say, as a result of this, the point expressed in Cartesian coordinate system as x equal 4 and y equal 3 meters is transformed to polar coordinate system with r equal 5 meters and theta equals 37 degrees. Now, what about if the point is given in polar coordinate system as r equal 5 meters and theta equal 37 degrees? How can we get the Cartesian coordinate axis or the point in Cartesian coordinate? Again, we have a right angled triangle where the hypotenuse represents the given r, which is 5 meters, and the angle theta is between this hypotenuse and the x-axis, which is the adjacent side. Using the trigonometric relation, cosine theta equal to the adjacent side x over the hypotenuse side r, we will be easily having the adjacent side, which represents the x coordinate, equals r cosine theta. It must be noted here that every adjacent side of a right angle triangle must be equal to the hypotenuse multiplied by cosine the angle between the hypotenuse and the adjacent side. Then in this case, substituting the values of r and theta, the x coordinate is 4. To get the y coordinate, we'll apply trigonometric relation sine theta equals the opposite side y over the hypotenuse side r, where y here is r sine theta. Substituting the values, you get the y coordinates equals 3 meters. In this case, the point given in polar coordinate system as r equal 5 meters and theta 37 degrees is transformed to Cartesian coordinate system with x equal 4 and y equal 3 meters. As an application on the transformation of a point from one coordinate system to another, let us take this problem where a point is represented in polar coordinates as r equal 5.5 meters and theta equals 240 degrees. What are the Cartesian coordinates of this point? Here it should be noted that r is drawn from an origin in the third quadrant to the end of its length, 5.5 meters, where the angle theta is 240 in the counterclockwise direction with respect to the positive x-axis. From the end of the length of r, if we draw a line projected on the x-axis, we will get the x coordinate. Now from the same end of the length of r, if we draw another line perpendicular to the y-axis, we will get the y coordinate. Doing this, it means the sides of the right angle triangle like this is x and y, while the hypotenuse is the polar coordinate value r, 5.5 meters. Here an angle of minus 60 can be drawn in the third quadrant. This angle minus 60 degrees is actually equivalent to the angle 240 drawn in the counterclockwise direction with respect to the positive x-axis. To find the x coordinate, r cosine theta, where r and theta are substituted as 5.5 meters and 240 degrees respectively. Here theta again, 240 degrees for theta is substituted in the cosine, is equivalent to minus 60 degrees. It can be also substituted for the cosine, and both give the same answer for x, which is minus 2.75 meters. For the y coordinates, r sine theta, where r is 5.5 meters again, and sine theta, where theta is the angle taken counterclockwise direction from positive x-axis. Again, this theta is equivalent to the angle minus 60 in the third quadrant. When substituted into the sine, we will get the same answer for y, which is minus 4.76 meters. Thus, the polar coordinates point with r equal 5.5 meters and theta equal 240 degrees is transformed to Cartesian coordinates with x equal minus 2.75 and y equal minus 4.76 meters in the This is another application for the transformation of a point from one coordinate system to another. In this problem, the Cartesian coordinates of a point are given as x equal 2, while y is unknown, and its polar coordinates are given as r, which is unknown, and theta equal 30 degrees. Determine part A, the value of y, and part B, the value of r. To solve this problem, in part A, we have to draw a right angle triangle whose sides are x and y, and the angle theta is the angle between the hypotenuse r and the adjacent side, which is x. Here theta and x are given, while r and y are unknowns. For part A, we apply the trigonometric relation tan theta equals y over x. X and theta are given, and then substitute into the relation to get y. Then y equals 2 tan 30, which is 1.15. For part B, to find r, apply the trigonometric relation cosine theta equals x over r, and solve that for r, where r equals x over cosine theta. Substituting the values of x and theta, we'll get an answer of 2.31.